In this video, we are going to see what is a logarithmic function. The logarithmic functions can be obtained from an exponential function. If x equal to b raised to y is an exponential function, we know that b is the base, y is the exponent. If x is equal to b raised to y, then the logarithmic function is going to be y is equal to logarithm of x to the base b. This exponent y is logarithm of x to the base b. Actually, the logarithm and exponential functions are reverse process. The logarithmic functions are used in several fields, like if we are trying to measure the force of earthquake or measuring sound intensity, if we are trying to find the doubling time and half time for the exponential change, you can make use of the logarithmic functions. The logarithmic and exponential functions can be graphed. If we are trying to graph this function y is equal to bx and y is equal to logarithm of x to the base b, since they are the inverse functions, one will be the image of the reflection of the other. When you're taking the line y is equal to x, if you're trying to find the image of this y equal to bx over the line y equal to x, you'll get the logarithmic function. And if you're trying to get the image of the logarithmic function over the line y is equal to x, you get the exponential function. The domain of these logarithmic functions are set of positive numbers, and the points on the logarithmic graph are to the right of the y-axis here. We can also graph the logarithmic function using the table what we have in our graphing calculator. So suppose if we are trying to find the equation y is equal to 2 raised to x or x equal to 2 raised to y, then for a given value of x we can find the different values of y and plot those point by point and graph it. The same way for x equal to 2 raised to y, we can plot the points point by point and we can graph it. The properties of logarithmic functions are very, very essential, and it says for any b greater than 0, b not equal to 0, these x, y, c's are all positive, c is also not equal to 0, then logarithm of 1 to any base will be 0. Here the base is b. Logarithm of b to the base b is 1. If both are b to the base b is 1. Logarithm of the product m and n will be the sum of the logarithms, logarithm of m plus logarithm of n to the base b. Logarithm of the quotient m divided by n is the difference between the logarithms. And you can also find the logarithm of m raised to x, the power rule. Logarithm of m raised to x will be x times logarithm of m. If we have logarithm of b raised to x to the same base b, according to the power rule the previous step, it is x times logarithm of b raised to b to the base b, and using property 2, we can say that it is just x. And the last property is logarithm of m to the base b equal to logarithm of n to the base b will give us a condition that the two values m and n are equal. This is true only when m and n are equal. Now, using this definition of logarithmic function, we can convert logarithmic to exponential and exponential to logarithm. So if we understand what these relations are, x equal to b raised to y implies y equal to logarithm of x to the base b, we can easily find what these values are. Simplifying this, we can say The base is 5, so 5 raised to the exponent 3 will be 125. In the second question, the base is 4. 4 raised to half will be 2. So the exponent is half. Base is 4. 3 raised to the exponent will be 1 by 27. So in this case, 8 squared is 64. Half raised to negative 4 is 16. 4 raised to 1 is 4. B raised to 0 is 1. B raised to 1 is B. And B raised to x is B raised to x. The same way, the reverse process, exponential to logarithm. 3 raised to negative 2 is 1/9. 1/9 is the exponential to the base. Logarithm of the exponential to the base will be the power, negative 2. Logarithm of the exponential 25 to the base 125 is the power 2/3. Logarithm of 256 to the base 2 will be 8. So here, logarithm of 27 to the base 3 is 3. Logarithm of 3 to the base 27 is 1/3. Logarithm of 1 by 100 to the base 10 will be negative 2. Logarithm of b to the base b is 1. Logarithm of 1 to the base b is 0. If we have an equation of this type, then we can easily solve that, because the first property is logarithm of the sum is logarithm of the sum of the logarithms is the logarithm of the product. So we have sum of two logarithms, so that can be written as logarithm of the product. We can simplify the factor as x squared minus 36. Now using the definition of logarithm, the base is 4. 4 raised to the exponent will be the power x squared minus 36. 4 raised to 3. 4 raised to that exponent 3 power will be x squared minus 36. So x squared minus 36 is 64. We can solve that and get two values, x equal to 10 and x equal to negative 10. But if we are taking x plus 6 and x minus 6, both x plus 6 and x minus 6 will be negative when x is negative 10. We cannot have negative of a logarithmic value. That cannot be negative. So we cannot have x to be negative 10, and hence the answer should be x is equal to positive 10. Let's try to find the value for x from this. The right hand side can be simplified using the power rule. It is logarithm of 8 to the power 2/3, 9 to the power half, and that 8 is 2 raised to 3, 9 is 3 raised to 2. Again, using the power, you can cancel out that 3, cancel out that 2, so it is 2 squared and 3. 2 squared is 4. So here logarithm of the sum is the product, and then the difference will be quotient. So when you simplify, you get the answer as log 2. Let us try to solve for x. The right hand side 1 can be written as logarithm of 10 to the base 10. We took this 10 because the base was 10. Suppose if the base was 5, we would have taken logarithm of 5 to the base 5. Or if the base was b, we would have taken logarithm of b to the base b. The left hand side is the quotient, x minus 1 by x plus 1. Now equating the two results, we get x minus 1 by x plus 1 is 10. Cross multiplying, we get x minus 1 is 10 times x plus 1. Expanding it, we get x minus 1 is equal to 10x plus n, or simplifying this result, negative 9x equal to 11, or x is equal to negative 11 by 9. So in this video, we talked about logarithmic function, the various properties of logarithm, and how to convert logarithm to exponential, exponential to logarithm. If equations are given in terms of logarithm, how to solve those equations and try to find the value of the unknown x. Thank you for watching this video, and thank you.